Hello and welcome. This is Pam. Today we're going to be discussing different types of protozoa that are linked to multiple sclerosis. So this is actually part 6 of a series that I'm doing of multiple sclerosis is an infectious disease. So we're talking about various different types of parasites that have been linked to multiple sclerosis. If you were ever weeding a garden, you're going to have more than one type of weed, and with chronic diseases like multiple sclerosis, we know that it's caused by a parasitic infestation. And so there are multiple different types of parasites involved. Today, the topic is talking about how protozoa play a role in multiple sclerosis. If we haven't met, my name is Pam Bartha. I was diagnosed with multiple sclerosis over 35 years ago. By the grace of God, I learned early on about how MS is an infectious disease caused by parasites. Over the years, we've learned a lot. We've worked with hundreds of students. So I'm going to be sharing insights we've learned from our students, a lot of research that I've done, and we're going to talk about 3 protozoa that are significantly linked with multiple sclerosis. When we think about parasites, a lot of times we think about worms. We don't always think about different types of, we think that parasites are worms, but parasites are basically any type of microbe that lives inside of us and causes us harm. So parasites could be worms, but they could also be bacteria and protozoa and fungi. So those are the 4 big main categories of parasites. So worms, we know there can be roundworms, flatworms. I've talked about some of those in previous of the series that I'm doing right now. Make sure to go check them out. I talk about roundworms. I talk about flukes. I will be adding in a few more video series because there are other worms that I haven't talked about. But then there's also protozoa, and protozoa are single-celled parasites. They're not the same as bacteria because bacteria are parasites that are a more simple structure, whereas protozoa have a more complex structure, more similar to the cells of the human body or to animal cells. And so they are a more complex, or I would say complex type of parasite. So they can cause, I believe they can cause more damage and more harm inside of us than even bacteria. And so when we talk about protozoa, again, being a single cell parasite, they can be found in our soil, they can be found in our water, they can be found in our food. They are all around us like all the other parasites. You may have heard of Giardia, which is often in our water in North America and other parts of the world. Maybe you've heard of malaria, which is a type of protozoa also. Babesia, which is another type of protozoa. Toxoplasmosis. There are many different types of protozoa. Some of them will not cause disease in humans and others will. And so today we're going to talk about 3 protozoa that are really significant in the symptoms they cause, the disruptions they cause in the human body, and how they're linked with multiple sclerosis. Let's first talk about malaria. And malaria is a single-cell protozoa that has been known for many, many years. But when we think of malaria, we think of, some other countries where, like maybe Africa, where malaria is. But actually, like in the early 1900s, there was an outbreak of malaria in North America. And so they were treating people with malaria drugs, and they noticed that people that had MS had significant improvements. Some of them would become basically symptom-free. And so I've done a 6-part series on multiple sclerosis and malaria for you guys to look at some other time. And you'll see that there is this huge history. There's, I'm sure, over 70 published papers, scientific papers on the link between malaria and multiple sclerosis and the significance of that. I'll just lightly touch on it here. But basically, malaria, again, is this single-cell parasite, but it infects our red blood cells. And it makes them sick, and it makes them sticky. And they stick to our blood vessel, the walls of our blood vessel. They clump together. They can actually block small blood vessels like capillaries. They can cause brain bleeds or broken vessels where we have bleeding. And so with multiple sclerosis, I've also done another video for you and another blog post about how, with all the evidence of the changes in our red blood cells and our platelets and the narrowing of the veins that they've known for years with MS, that MS is more of a vascular disorder than it would be considered an autoimmune disease. And all of this stuff that I'm sharing with you is ignored. It is completely ignored with the different protozoa and all the different worms, etc., by the expert panel that decides how we diagnose and how we treat multiple sclerosis, which is really, really unfortunate. So with malaria, there are many different symptoms that we can have. And we're not talking about acute malaria. We're talking about when malaria, or I should say that it's called Plasmodium. That is the actual protozoa that causes malaria. When this protozoa infects our brain and we have cerebral malaria. So this is what we're talking about with diseases that are neurodegenerative diseases like multiple sclerosis. So of course you can have fever and fatigue and you can have an acute infection, but when this parasite, for example, it infects our red blood cells and it might cause little blood vessels to burst in our brain, you know that if there is a broken blood vessel in the brain where all of this material from our blood vessel is pouring into our brain, our immune cells are definitely going to go to work cleaning up the mess, and there's going to be inflammation. That's the immune system is working really hard. So with that, then the research has shown too that around every lesion, well, number one, the lesions are centered around a blood vessel in the brain. That's a really significant part. And then on the outside of every lesion, they found that there's this ring of iron. And that would make sense too, because if you have a broken blood vessel and you have a bunch of red blood cells moving into the area, coming from the blood vessel into the brain, then the immune system is going to break that down and you can have deposits of iron. So this is really, really significant. And again, it's not just that we see changes in our red blood cells, but also these doctors years ago were treating MS patients with malaria medication and having incredible improvements. And all of a sudden, like around the 1950s, 1940s, 50s, 60s, there was a shift away from MS as an infectious disease to MS and all chronic diseases are autoimmune diseases. So there was that big shift. So I'm going to create a blog post for you, and that will be on our website, livediseasefree.com. And that will be by this weekend, and you will be able to go through my notes and you can see, like, just in a general sense, like the symptoms they cause, the research behind it, the blood tests, treatments, etc. So for example, like the treatments would be malaria drugs. So the CDC recommends artesunate, which is an injectable form of wormwood, or artemisinin is the herbal form of wormwood, so that can be helpful. But if you're just doing wormwood, it's hard to get it into the central nervous system, and that's why you need something that works more systemic if you have cerebral malaria. Quinine and there's hydroxychloroquine or chloroquine. So, and that's really interesting because like some people that have lupus or arthritis, they're actually treated with malaria medications to help manage the disease. Isn't that interesting? Yeah, so there's a lot of overlap between these different types of parasites. If you'd like to learn more about the link between malaria and multiple sclerosis, just do a Google search and look for Live Disease Free MS and Malaria, and you'll find a several-part series. So this is really, really big, like really significant. This is not a stretch. There's tons of evidence, tons of research from dating back to like over 100 years ago, which is crazy, and over 75 studies. So this is a very significant protozoa that is linked to multiple sclerosis. And modern studies, again, show this connection with vascular disorder and multiple sclerosis. I'm going to share with you on my blog post on my website different links to this, to the research. And another really important, more current, there was a study done, I think, just less than 5 years ago, where they gave people that had multiple sclerosis, that had progressive multiple sclerosis, they gave them a malaria drug, and they noticed that it actually significantly decreased their progression of the disease, of the MS, by giving them a malaria drug, which is crazy. So there's a lot of similarities in like vascular disorders and blood abnormalities with MS and malaria. So number one, we see that red blood cells clump together in both malaria and MS. We can see platelet abnormalities in both multiple sclerosis and malaria, also anemia in both, and reduced blood flow in both, high blood pressure in both, heart failure in both. All of this I'll share with you on my blog post, so you can literally just share this with others, share this with your doctor, and immune suppression. So this protozoa and this is very similar with all of them, they suppress our immune system in different ways, and that makes us more susceptible to other parasites. So with malaria and multiple sclerosis, we see our B cells and our T cells are involved. Immune dysfunction that is observed in multiple sclerosis. So, and once you treat malaria, then these T and B cells normalize again. Let's talk about Toxoplasma, and it causes the condition called toxoplasmosis. Last week I talked about how certain protozoa can really impact our glutamate. And glutamate is a neurotransmitter that it's really involved in how our nerve cells communicate with each other to pass these signals from one nerve cell to the next. And what we find with different parasites like toxoplasmosis and also malaria, the protozoa that causes malaria, which is Plasmodium, that they disrupt the glutamate. So this neurotransmitter, it has to be in a very precise amount. Too much of it is going to excite the nerves too much. It could damage the nerves, and not enough of it, we're not going to have the proper signaling with the nerves. So when we have these chronic protozoal infections that move into the central nervous system, like toxoplasmosis and possibly malaria, then we notice, or that I should say the research has shown, there is a disruption to glutamate and it's increased, which is very likely going to cause, which does cause damage to nerves, frying your nerves basically, and they're finding higher than normal glutamate in the lesions of MS in their brains of patients, but also higher glutamate when we have higher or greater or quicker progression of the disease. So this whole disruption in glutamate is really significant in multiple sclerosis. I knew this was significant in ALS years ago when I was studying it, but I did not know that it was so significant also in multiple sclerosis. Not just MS, but Parkinson's disease and Alzheimer's disease, ALS, and even schizophrenia. So there are many different diseases where there is a really significant disruption or dysregulation to our glutamate, which causes our malfunctioning of our nerves, right? Overstimulating, all kinds of things can happen. Really, really significant. And the research, if you look on my blog post from last week, there are a lot of studies all the way dating back to 2005. So we're talking about 20 years, over 20 years, they've known that glutamate is disrupted in multiple sclerosis. And again, why are these experts not interested in figuring out why? They're like, no, we don't want to look at anything if they have lesions, or if we look at the spinal tap and there is a antibody bands. That's all. We don't care how they got there. We don't care what it means. We just look for those two things, and then we can prescribe the MS drugs. This is so bad. It's just so irresponsible. To me, it's really criminal. And when you are an expert and you are on the expert panel for the entire world dictating how MS is diagnosed and treating, you have a responsibility to research this and to prove that MS is not caused by these infections, when we know that when these protozoa are in the central nervous system, they cause all the symptoms of MS also, and other diseases like Parkinson's and ALS and Alzheimer's and many others. So it's awful. So with toxoplasmosis, we can get this through many different ways. It's a really common protozoa. At least 30% of the world's population has this protist. But if your microbiome is really in balance and you are very strong, then you probably won't notice an issue with it. But it's for people like myself that I was on antibiotics for several months for acne and also for other things. Back in the day when I was young, our doctors would prescribe antibiotics really liberally. And so whenever we'd have a sore throat and a temperature, we'd get antibiotics without even doing a culture. And our doctor was trying to do his best, but he didn't know that he was really disrupting our microbiome. And so then I was really susceptible. We had cats, and they definitely can be shared from cats and other animals and food and probably in our soil, like a lot of the parasites. So we're exposed to parasites, but we're supposed to have this natural defense, this ecosystem of health-promoting microbes that defend us. But a lot of us, ours is really compromised, and then we're susceptible to having these infections. And then if our immune system doesn't resolve from them, then they move into different parts of the body. And Toxoplasma is known that it really likes to inhabit the brain. And then we end up with cysts in our brain from this parasite. And so it's very, very serious. We can get it even from undercooked contaminated meat, from contaminated water, contact with cat, and also congenital transmission. So it forms cysts in the body, and it can persist in the brain. And again, the biggest thing that I found, well, number one, it can cause a lot of immune suppression, which is very significant, right? That makes us more susceptible. So it's like, which came first, the chicken or the egg? Is it the toxoplasmosis or the Babesia malaria or the big worms? Which came first? But it doesn't really matter. When we're recovering, we want to treat all of them. So some different types of symptoms. The acute is not really relevant to multiple sclerosis. It's more when it's getting like a chronic stage and deep in our body. But we can have so many different types of symptoms, even seizures and confusion, so cognitive dysfunction, visual disturbances, and encephalitis in the brain, swelling in the brain. It can even be linked with tinnitus and with floaters and so many other symptoms. So do I believe that any one of these protozoa are the only cause of multiple sclerosis? I don't believe that, but I believe that and this is what we've seen in some of our students that have been energy tested, that some of these integrated practitioners have picked up Babesia, or they have picked up toxoplasmosis, and maybe it's not always the same in every student. It's what we're exposed to, but they can cause very similar symptoms. And so, again, the disruption in glutamate is a really big part of the problem, but also triggers low-grade inflammation, immune suppression, and which really alters, like especially the glutamate disruption really alters the functioning of our brain, inflammation of our brain, our nerves, damage to our nerves, etc. There are different treatments. I will put them on the blog post, but this is something you'd want to talk to your doctor about. So with toxoplasmosis, which is the protozoa Toxoplasma, there are some studies that say that it's not really proven that it's linked with MS, but then there are other studies where they have found a significant association with MS and this protozoa that causes toxoplasmosis. And so to me, it's kind of like, well, if you didn't prove it, maybe your study wasn't done well enough. But if you have shown, when you're using controls that don't have MS, and you look at MS and you compare, the amount of people that have toxoplasma, and you find that it's like double with MS, and there's a few studies like that, to me, that is a stronger case. So the verdict or the jury is out on this, but research is suggesting that toxoplasma definitely can play a link in multiple sclerosis. So one study, 2017 study, They looked at 200 MS patients and 200 healthy controls, and they found that Toxoplasma was present in 60.5% of MS versus 28% in the healthy controls. So that's basically double. It's over double the number of people that had Toxoplasma that were diagnosed with multiple sclerosis. And then another study, it was a little bit smaller of a study, they found that 44% of people that had MS had Toxoplasma, and the other controls, the healthy controls, it was only 24. So again, it's about a 50% higher, which is significant, amount of people that showed that they had Toxoplasma that had multiple sclerosis versus healthy people. And so this research really, and also how Toxoplasma impacts our nervous system with the glutamate connection and immunosuppression, it really shows that this is likely, for some people that have MS, that this could likely be something they need to treat. And you have to remember that the treatment is going to have to deal with treating the central nervous system, using parasite drugs that will treat the central nervous system, not just what's in your blood. Let's talk about the last one, Babesia. So Babesia is a type of protozoa. Think of it very similarly to malaria. So it is another protozoa that infects our red blood cells, causing them to be sick and clump together, become sticky. They will stick to the lining of our blood vessels. And can cause narrowing, inflammation. They can also stick to the small blood vessels in the brain, can cause a blockage, and then we can have a rupture of our small capillaries or small vessels in the brain. And this can be really terrible because it is compromising and really impacting our blood-brain barrier. And the blood-brain barrier it really keeps certain things out of our brain, and it only allows specific things to go into our brain. So when we have a broken blood vessel in our brain, then all of a sudden everything that's in that blood vessel spills into our brain. And then our immune system is definitely going to go to work to treat that, to clean it up. Malaria and babesiosis are treated very similarly. And malaria is caused by Plasmodium, and babesiosis is caused by Babesia. So Dr. Klinghardt, I just wanted to share, he's one of the hero doctors that I study under. He has a lot of experience with Lyme. He works with a lot of Lyme disease patients. And he shared that patients with chronic neurological conditions like multiple sclerosis and severe depression almost always have underlying Babesia infections. He cautions that current tests are not accurate enough. They are insufficient to rule out the presence of Babesia in these patients. So we'll talk about a few of the symptoms here. So with Babesia, we can have night sweats, and that's really common. Air hunger, maybe when you're walking up a hill or you're going up the stairs and you're winded, you're like, I shouldn't be winded. This is not that hard, but you just can't catch your breath. Insomnia, heart palpitations, dry cough, petechiae, which are small little broken blood vessel. You'll notice them more so on your torso as like little blood blisters, very small. And tinnitus and easily bruising and red. If you look at your blood work, if you notice that you have the width of your red blood cells would be wider, maybe the red blood cells, there's less of them. Your MCV, MCHD can also be increased, so the width of the red blood cell is bigger because they're infected. So you'll see and even platelets. So you'll see abnormalities with your red blood cells and possibly your platelets. Not always, but if you do, that is often a very strong indication that you may have one of these parasites that you've got something infecting your red blood cells, which likely is something like malaria and Babesia. And you think, we have malaria like this, that's not something we have in developed countries, but yes, we do. And you can actually see that it is present. It is passed by mosquitoes. we're not really testing for it. We're not looking for it. So it's not something that they're going to pick up. Even if somebody went into the hospital with malaria, they're not going to really pick it up very easily, because it's not like, if they haven't left the country, they're not going to look for it, right? So that's a really important thing to know, is that, our tests are poor. Even just the doctors being able to recognize that we might have this is very, very poor. There isn't a lot of research showing that Babesia is linked to multiple sclerosis. I did find one case study where there was somebody who has MS, and they were found to have a babesiosis or Babesia infection. But this is a neglected parasite, as many of them are, that they're not even looking for it. It's just like with Lyme disease, they're not really looking for it unless we ask. And so like Borrelia would be a bacteria, and that's why we're not talking about it today. But Babesia is one of the vector-borne infections associated with Lyme disease. It is a protozoa, protist, and it infects our red blood cells, and it's really linked to multiple sclerosis symptoms. Again, multiple sclerosis is just a collection of different neurological symptoms caused by various types of parasites, and it might not even be the same parasites in every single person with multiple sclerosis. That's the frustrating part, and I believe that's probably why, a big reason why we haven't found a cure yet. Right now, we're not looking for a cure. It's like they dropped looking for a cure, and that's what we want. Those of us that have multiple sclerosis, we want a cure. Can we have a cure? Absolutely. If we go looking towards the cause, if we start to go, why is glutamate disrupted in multiple sclerosis? What kind of parasites could cause this? Oh, toxoplasmosis. Oh, malaria. Oh, I wonder if these patients have these types of infections. Why is there elevated glutamate in MS patients? What kind of infections can cause this? Why has Dr. Alan McDonald found all of these small roundworms in the central nervous system of every MS subject he tested? Also, tapeworm larvae and developing tapeworm in every MS subject he tested. Also, finding all these other parasites like Borrelia, which causes Lyme disease, and also finding Borrelia in the nerve cell, like in the myelin sheath of nerve cells. So there's this huge mountain, and I've been talking about this for so long and sharing so much research with you, but it is only going to change when, number one, you take charge of your own health and you move in a different direction and you start to treat these parasites, working with practitioners, working and getting support. This is something that you can't do on your own at the start. And then sharing this with practitioners, sharing all of this research. Eventually, they're going to come around, and eventually they're going to start to treat parasites. But I pray that I will be alive. I don't know if it's like several hundred years. No, I don't want to be alive. But if it's in the next few years, I would love to see this change, because I would be jumping up and down for joy, so grateful that people would be getting the care they need. And especially early on, we could avoid so much chronic disease if we would treat parasites early. This is where we're at right now. So you can either wait for maybe 20 years before our doctors are going to treat parasites, or you can get on the bandwagon early on and you can treat, recover, get on with your life, and never just like close this chapter of your life and move on. And that's what I highly recommend, because it's a lot of fun being super active and doing all the things you love to do again. So with that, if this is the first time you found our work, please like, share, and subscribe. Or if you've enjoyed what I've shared, please share this information with different practitioners. It doesn't have to be doctors. It could be chiropractors. It could be nurse practitioners. It could be functional medicine. It could be massage therapists. It could be physiotherapists. Just anybody who wants to listen, because colleagues talk to each other, and sometimes they're part of bigger clinics where they have different types of practitioners in clinics. And so there is a growing interest of parasites in chronic disease, but you can help bring this information to them so that they can understand how parasites directly and indirectly cause disease, whether they're changing the physiology inside of us, or whether they're directly damaging tissue and causing inflammation because our immune system is fighting. And so as soon as we get them to believe in this, then we can start to train them up in how to best treat these parasites. And if you need support, make sure to watch my masterclass training, How I Have Recovered from Multiple Sclerosis, and many others. You will love it. I go over all the steps we take. I share the different research of the most common parasites and also the steps we take to recover, lots of case studies. So it's all there in my masterclass training. So with that, I'm going to let you guys go. I hope you have a wonderful week, and I will talk to you next week. Take care. Bye-bye for now.